Hello friends, welcome to my channel. Today we'll discuss about polymorphism in C#. What is the agenda of today's video? First, we'll discuss what is polymorphism, benefits of polymorphism, real life example of polymorphism, followed by a demo. Before that, if you are new to my channel, please do not forget to subscribe. And if you want to learn encapsulation and abstraction in OOPS concept, you can refer to my previous video. Let's get started. What is polymorphism? Polymorphism is a crucial concept in object-oriented programming that allow objects of different classes to be treated as an object of common base class. In C#, polymorphism is achieved through inheritance, method overriding, and the ability to work with objects of derived classes using reference of their base class. This concept enhances code reusability and flexibility. Polymorphism in object-oriented programming comes in various forms. What are the different types of polymorphism we have? First one is compile-time polymorphism. Compile-time polymorphism can also be called as static polymorphism. We can achieve static polymorphism or compile-time polymorphism using method overloading or early binding. Second is runtime polymorphism. Runtime polymorphism is also called as dynamic polymorphism. Runtime polymorphism achieved through method overriding or late binding. Next, polymorphism through interfaces. Interface define a contract that classes must adhere to by implementing their methods. Next, parametric polymorphism or generic polymorphism. Generic allow you to define classes, methods, and interfaces that can work with various data types. We'll discuss types of polymorphism in more detail in our upcoming video. There are some key advantages of polymorphism. First one is code reusability. Polymorphism allow you to define common behavior in the base class and then reuse the behavior across multiple derived classes. This reduces redundancy and promotes modular design. Next benefit is flexibility and extensibility. New classes can inherit from existing classes and provide their own implementation, ensuring that existing code remains untouched. Next, simplified interface. Polymorphism abstracts away the detail of specific implementation, allowing you to work with object at a higher level of abstraction. Then, dynamic binding. Polymorphism enables dynamic method invocation. This actual method that is executed is determined at runtime based on the object type. This dynamic binding improves the flexibility of our code. Easier testing. Polymorphism allows you to create mock object and substitute for testing purpose. This is especially useful when we write unit testing, as you can replace real object with simplified version of testing. Next, reduced coupling. Polymorphism reduces the coupling between classes. Classes that depend on a common base class or interface can interact with each other without needing to know the specific implementation details. These are some benefits of polymorphism. Let's explore a real-life example of polymorphism. This time, we'll use the concept of employees. Consider a scenario where you are building a system to manage different types of employees in a company, each with their own roles and benefits. Let's see how we can apply polymorphism to model different types of employees. Here is my Visual Studio. Now what we'll do, we'll first create a base class with some properties. So our base class will be employee. I'll create a class. I'll name it as employee. I'll make this class as abstract class. Then we'll introduce a property called name. Is of type string. Next, we'll create an abstract method to calculate salary. Now, this is our base class called employee with a property called name and an abstract method called calculate salary. Next, we'll create multiple derived class. One will be for regular employee and next one will be for contract employee. So I'll create a class here. This will be my normal class, that is public class regular employee, and I'll inherit it from my base class, that will be employee. Next, we'll create a property, monthly salary. It will be of type double, and here I'll specify monthly salary. Since regular employee inherited from employee class, we have to implement the base class method. So what I'll do here is I'll create the base class method, that is calculate salary, and here I'll return employee's monthly salary. Next, we'll create another class called contract employee. What I'll do here is I'll copy this class and I'll rename it to contract employee. For contractual employee, we do not have monthly salary, instead of we have hourly rate. So what we'll do here, we'll rename it to hourly rate or hourly pay, you can say. Next, we want to keep the track how many hours a contract employee worked in a day. So to do that, we'll introduce another property. Here, we'll keep track of the hours that a contract employee worked per day. So here I'll mention that hours worked. Next, we'll implement calculate salary. To calculate the salary of contract employee, we have to multiply hourly pay into hours worked. That is hourly pay into hourly hours worked. What we did in this example, the employee class is the base class with a property like name and a method called calculate salary. Next, the regular employee and the contract employee classes derived from employee base class and provide their own implementation of calculate salary. Next, we'll go to program.cs file. Here, we'll create object of both the classes, that is regular employee and contract employee. To do that, what I'll do here is I'll write var regular employee is equals to new regular employee, and here I'll specify the name of the employee. So name is equals to, maybe I can say John, and monthly salary is, for example, 5,000. Next, we'll create an object of contract employee where contract employee is equals to new contract employee. Name I'll give you Bob, and pay is, for example, 20, and our work equals to 160 per month. Next, what we'll do, we'll calculate the salary and print the salary. So I'll create a method here, calculate salary, calculate and print salary, and here I'll pass the employee, that is regular employee. Then same method I'll copy and I'll pass employee as contractual employee. And here we create a method called as calculate and print salary. What I'll do here is I'll just call the calculate salary method for both the employees. So I'll write var salary equals to employee dot. Before that, we'll make it generic since both employee will be here. So I'll name it as employee and pass as employee. So this is our abstract class. Now what we'll do here is we'll call employee dot calculate salary. So what it will do for regular employee, it will call its own implementation, that is calculate salary of regular employee class, and for contractual employee, it will call its own calculate salary method. Now what I'll do here is I'll just print the employee name and its salary. We are done with the implementation. Let's run our program. Now we can see the output here. John, which is a regular employee, and its salary is 5,000 since we have passed here 5,000, and our contractual employee is Bob, and his salary is 3,200, which is multiplication of 20 into 160. Let's discuss what we did in program.cs file. First, we create object of regular employee and contractual employee. Then we call calculate salary, calculate and print salary method by passing each employee, that is regular employee and contractual employee. Despite the method is being defined to accept employee object, it can work with instance of both regular employee and contractual employee due to polymorphism. The appropriate overriding methods are called based on their actual type of object. This real life example demonstrates how polymorphism allows you to model different type of object with shared behavior, that is calculating salary. It enables you to treat different types of employee uniformly and helps in creating a structure and adaptable code base. You can reuse the abstract method in each subclasses, that is employee and that is regular employee and contractual employee, and they can do their own implementation. This is how polymorphism works. Next, we'll discuss about inheritance. So stay tuned for my upcoming video and don't forget to hit the like button. Thank you.